comparison for OD-134. The position delta is now 148.1 meters. As a reminder, the previous was 157.2.
Copy. Do you mind sharing the table briefly?
Will do.
Copy. Thanks, Tad 1. If you have the B-plane handy, can you add it to it? If not, I can switch it.
Yeah, I think I have it.
Actually, I only see 133 in my email.
I'm showing the 134 B-plane too.
Awesome. Thank you. All right, we finally see a little bit of the twist we've been looking for here in the end game. All stations on M20 ops. We're about 15 minutes out before I'd like us to take shorter breaks. So just a reminder, if you want a little bit of time off net to stretch, now's a good time. If you hadn't had any peanuts and want some, feel free to do that while you're out there as well.
Hello, everybody. Hello, Martians. Welcome to WeMartians Live. My name is Jake Robbins, and I'm actually vibrating with excitement right now. I'm so stoked for what we're doing today. NASA's Mars 2020 rover, the Perseverance rover, is landing on Mars today. It is currently barreling towards the planet at some ungodly velocity. It is already inside the orbit of Deimos, and it's about an hour away from touching down. So it's a big day. This is really exciting. So if you don't know me, of course, I'm regularly a podcaster. Audio is usually my thing. But this is not every day that you get to have a Mars rover land on Mars. And we want to do something special. So just like we did back in July with the launch, we're doing this really fun YouTube live stream. And also, just like we did in July, I'm recruiting help because I can't quite do this on my own. So I have a co-host joining me today. I'd like to welcome to the stream Dr. Tanya Harrison. Tanya, how are you?
Good. How are you?
I'm excited, as you can tell. You're a planetary scientist, professional Martian. You're an author. I see a book there behind you. We're going to talk about that later. And you're also, let's see if I get this right, Director of Science Strategy at Planet Labs Federal. Did I get it?
Yes.
Yes.
Just a few things.
Just a few things that you do in between all your other activities in your spare time. How excited are you today?
Oh my gosh, it's like Martian Christmas. You don't get, like you said, you don't get launch and landing days very often. So when they happen, it's just like excitement all around. I love it so much.
Yeah, I woke up at about 5:15 this morning, and my eyes were just like wide awake, and I'm just like running through the events of the day, and I'm just super, super excited. So we have some fun things to share with you guys. So we're going to do a little bit of logistics here first before we get into our special guests. So behind the scenes, we have our good friend Anthony, who is running the show. He's pushing all the buttons. He's the man behind the screen. And he's going to bring up the live stream from NASA for us here. So what we're going to do is we're going to have, this is the Jpl Raw Feed. It's got just kind of some call outs on the net. We'll have that up kind of throughout the stream in different places, sometimes down below here. Sometimes you'll see it up in the corner somewhere. And we're going to try and keep that as well as we can. And when we get closer to the landing, we'll try and bring that up and make it more the focus as well. So just keep an eye on that. And I also have something really fun to share with our countdown clock. So Anthony, if you can bring up the countdown clock. So this is something that we put together for this stream here. So you've got a clock at the top there, which is the time until touchdown. So you can keep an eye on that. We're an hour and 6 minutes away now. And you're going to see some different events up on the queue there. So these are different milestones throughout the mission. And as they get closer, they're going to expand and kind of show some information for you. So if you don't know where we're at or what's happening, you'll be able to see it up there. I will add, this is an experimental timeline. This has not been tested for a live event until right now. We do not have a live feed from JPL telemetry. They do not let podcasters have those API keys, so you can't just
come on, Jake,
log in. I tried, but they just wouldn't answer my emails and that kind of thing. Yeah, so it's pre-programmed events based on data that NASA has put out, and we put all those in there. So it should be pretty accurate because these EDL timelines are kind of set in stone. The only caveat for that will be closer to the actual landing when the parachute deploys, because as we will talk about later, Perseverance has some cool dynamic control over its landing. And when the parachute comes out, will move by a few seconds here or there. If that does happen, our producer, Anthony, does have fine controls. He can tweak that. So we'll see how difficult that is for him to do on the fly. But we're going to do our best. But, it should be accurate within, I would say, 5 seconds or so. And hopefully that's all good to go. But yeah, that's kind of the timeline. So maybe we'll go through a little bit of our schedule today. Anthony, can you bring up our schedule? And then Tanya, maybe you can talk a little bit about some of the guests that we have coming up on the stream today.
Sure thing. We have some really exciting guests today. First off is kind of a bit of a Canadian takeover between Jake, myself, and Debarati Das, who is at McGill University. Debarati is a planetary scientist who is a member of the Curiosity science team who's worked with the Laser-Induced Breakdown Spectroscopy Instrument, or LIBS. It's the fancy name for the laser that blows up rocks on Mars to tell us what they look at. And then we've got Dave Buecher from Lockheed Martin, and he's the aeroshell program manager for the Perseverance mission. Lockheed has built all the aeroshells for all of the rovers that NASA has sent to Mars. So he's got a lot of experience in what we're going to experience through that 7 minutes of terror. And then for the last up, we've got Mike Seibert, who used to work at JPL on the Mars exploration rovers missions. So Spirit and Opportunity for ages. So he's definitely got a lot of stories and experience on what it's like to work on these rovers.
Yeah, it's going to be an exciting lineup here. I'm pretty stoked for it. We've got a little bit of science. We've got a little bit of engineering. We've got a little bit of operations. It should be a good kind of, a good diverse palette of expertise that's going to share with us. And then after those guests, we will head right into the kind of the fun events. So the mission critical events, if you will, start at about 12:38 Pacific. That's a crew stage separation. And then there's about a 8 or 9 minute gap before the infamous 7 minutes of terror. And I don't know. I haven't scheduled much for that. We're gonna just see what our emotions do to us, Tanya. I don't know. I don't know how I'm gonna react.
We'll just sit here like nervously eating the good luck peanuts.
Yeah. I've got my peanuts too. I was mentioning earlier, they are kind of cheap dollar store peanuts. So I hope I haven't cursed the mission by not getting premium high quality peanuts. But we'll see how it goes.
This is the low-key way of saying that you all need to back WeMartians on Patreon so that Jake can afford not dollar store peanuts.
Yeah, I went full-time in January, and I'm on a shoestring budget right now. So dollar store peanuts it is. Cool. Well, what do you think? Should we just get into the guest right away here and see where it takes us?
Let's do it, yeah.
All right, so maybe we'll bring on Debarati Das. Hi.
Hey.
Hello. How are you doing?
Good. We're really, really excited to have you today.
Great.
How are
you
doing?
Thanks for having me. Very excited. Really hoping the landing goes well, so that I can do more projects on it. And no big deal. Just
some career stuff hanging on that.
Just some career stuff.
So Tanya, I don't know how you want to do this. I've got some questions. You've got some questions. Do you want to start us off with us?
Sure. I guess, Debarati, you've worked on the laser instrument on Curiosity. So what are you most looking forward to with the laser instrument on Perseverance? How is it different? Is it going to tell us anything new?
It's called SuperCam. We had ChemCams. I think it's a super version of it. Lots of cameras, which are going to be better resolution and color. So I'm definitely looking forward to some very pretty pictures. I'm also a little biased because of my research. I work on veins, calcium sulfate, evaporite veins in Gale Crater. So I'm really hoping to I'm really hoping to see more of those images because they kind of tell us about the last bits of water that was present on Mars. I'm kind of really looking forward to those images.
Nice.
So tell us a little bit about Jezero Crater itself. I mean, why would we go to Jezero Crater?
Right. So thanks for pulling up that image. That's a great image. Jezero is quite special because it has this really neat delta. It's a pretty ancient crater, and it used to have a lot of water, and we can tell because it has some major rivers running into it, and it has this beautiful, large river delta. And on Earth, river delta is often associated with a lot of organics being trapped into it. And looking at the size of this delta and some of the evidences that we've seen around the rim, we can tell that there was a lot of water which was around for a long time and even overflowed out of the crater. So that kind of shows that there was enough water for a long time that may have sustained life. And right behind this delta on the left side, you can see this arc near the rim where scientists even detected some carbonates. And when you say carbonates, I think geologists get really excited because carbonates, like limestones, are often associated with living organisms like corals and fossils that preserve life. So I think these are some really great candidates to look for life if that's the goal of the Perseverance mission. And these are some really great candidates to...
Is that kind of green area you're talking about there, the carbonates? That's the arc?
Yeah, the green and the bluish area. So that's where I think it was a chrism image which kind of like lit up white, saying that, look, there are some hydrated carbonates here. And the delta itself has some hydrated clay minerals, which are really good at... the clay minerals are often associated with biologic activity. So again, super great for looking at, possible life-related activities on Mars.
Yeah.
I think
really love, I was going to say, I love the Jezero just because there's so much going on there, because this delta has just like brought all these rocks from like all over Mars and putting them all in one place. It's kind of like, if anyone's familiar with the Mississippi River Delta, think of how much the United States is covered by the Mississippi. It brings so much all into that one spot and then outpours it out in there. And that's basically exactly what's happening here. So it's just so exciting how like all the different colors just show with all the different rocks too, right?
Exactly. I think it's also really neat that it's right next to a very flat surface. So it's like, hey, safe area for landing, also really neat clay minerals and carbonate. So yeah, I think they did a great job at choosing this landing location.
It's really convenient for us.
Yeah. It's like Mars was just saying, we have this, so just, come over.
So we're going to be doing some sample collection with this mission, which is probably one of the headline events, right? So Perseverance will be picking up some rocks, different locations, all these different rocks that we're talking about as it goes up the delta and outside the crater. It's going to leave those behind. Another mission is going to come pick them up, bring them back. I know, Debarati, you've done a lot of work with sample collection here on Earth. You've got a lot of experience with, what that process is and why we do it. Can you talk about sort of sampling in general and why it's really important, and then maybe what's exciting about Perseverance and its samples?
Right. Awesome question. So a lot of times we kind of draw comparisons between what Earth is like and what Mars is like. And I think it's a great way to understand that physical processes might be similar on Earth and Mars. So it gives us an idea of what might have happened on Mars when we look at areas on Earth that sort of is similar in terms of environment on Mars. But this sample collection mission is really exciting because even as we are doing sample collection on Earth, like I collect calcium sulfate veins in Death Valley. I think we have an image of that. Yes, I love this image. So we collected some samples from Death Valley 2 summers ago. At the same, like, these are great, but at the same time, these are still from Earth. There's still, we have to account for the differences between the environment of Earth and the environment of Mars. No matter whether we're running simulations on Earth labs, we still have to say that here's how different Mars is, and this is all under the assumption that this comparison only goes up to a certain extent. So what's exciting about getting samples from Mars is that we won't have to be like, okay, this formed in an oxygenated atmosphere. We get samples from Mars. That's going to be like Christmas for scientists, and it'll keep going. It's going to be like a gift that keeps giving. And we also have far more instruments that are higher powered on Earth. So we analyze these samples. There are some analysis that we can't do on Mars, like radiogenic dating. So we get to know far more about Mars by bringing those samples to Earth, and without the risk of losing lives. Although they're kind of expensive, far more expensive than just collecting some samples from Death Valley. But yeah, that won't be there. We'll actually get samples from Mars and be like, this is the real thing.
So you mentioned the dating. That's one I'd follow up with, because I know that's in geology, and the two of you can both make me sound way smarter than the answer I'm going to give here. But in geology, you kind of have those two different ways of aging things. You can do relative aging. You can go rock A is older or younger than rock B, and then absolute aging, which is like rock A is precisely 13,000 years old, or whatever the number is, right? But the absolute aging is, we haven't been able to do a lot of that on Mars, right? And so we have good relative ages between different spots on Mars, but the absolute aging will really help us, right?
Yeah, definitely. I think a lot of that has been done based on crater counts, and it's just that, yeah, it takes equipment to kind of do that, and that's going to be really helpful with the samples. And
we've
also,
been basing it off of, we've also been basing it off of crater counts on the moon, right? So we're extrapolating from the moon to Mars, but we don't necessarily know that's accurate. So it'll be interesting to see how these dates line up.
That's the stretch, right? So it's like you go to the moon, you get a sample of the moon, you absolutely date it, then you crater count and match it to that absolute date, and then you take the crater count and match it to the crater count on Mars, and then try and back. It's like crazy math to try and figure out how old these rocks are. Yeah, we need to get over that and get some samples back.
Another thing is that when we're looking for life, I think it's really hard to tell what is evidence of life, definitive evidence of life. So I think the point is to really understand or like detect something that's like very definitive in terms of biologic activity, and once we bring that back, only through human knowledge, experience, and intuition can we tell that, yeah, okay, this is actually really life. So having those samples in front of your hands and being like, okay, we really, really see this, will definitely help us tell more about how much, life or the possibility of life there actually was on Mars.
And we can finally look for definitive things, right? Like DNA, instead of hand-wavy things like biosignatures, which are indicative of maybe there was life at some point, somewhere, someday. But DNA is like the thing that we need, right? And so what are you hoping that we're going to learn from the samples that actually come back and we look at them in a lab? What other things can we do with those samples, like the kind of stuff that you're doing in Death Valley that we aren't able to do with the rover on Mars right now?
That's a great question. However, I'm not very trained to look at biologic activity, but I think I've heard a lot of words. In general, I think, there are words like kerogens. When you talk about life, you see these stromatolite-like features, which is kind of, it's also difficult to kind of say that a lot of people will be like, oh, this is life, this is not life, and it's like an ongoing discussion about what exactly counts as life. Even when you look at really, really old life signatures on Earth, it's really difficult to say. So when we say we really want definitive life evidence, I think, it's not like we have high expectations, but I think we'll have to be prepared to really kind of know what we are looking for in terms of those. And I don't have a lot of information about that. I think, to me, the things that come up are like stromatolites and kerogen and organic molecules. But I don't know if you'll find it. If we find sulfates, I'll be super happy. I'll be like, oh, there was water and water-soluble elements like boron and lithium. And I'll be like,
I was going to say, you're going to be looking for the boron, aren't you?
Yeah, the boron. Like, check. It's all great. There could have been life. But then again, it's not, like Tanya said, it's not we're not looking for hand-wavy evidences. I'm sure the astrobiologists out there know what they're looking for.
Yeah. Awesome. Well, Debarati, this is really fun. I'm so excited for the science that you and everyone else is going to be doing with this rover when it touches down and gets to work. Thanks for coming to share some of this with us today.
Thanks for having me.
Yeah, we really appreciate it.
Hope it lands.
Cool.
Happy landing.
Yeah.
Happy landing.
Awesome. So so let's see. We're about 50 minutes away from the landing here. Tanya, I was just thinking, like, the talking about the cool observations that Perseverance can do, and I'm thinking back to like the initial rovers, thinking about like Sojourner, Opportunity, Spirit. You've done a lot of work on those. Give us a sense of like how far the science has come. Like, the questions we were asking 20 years ago with Sojourner versus now 25 years ago. It's getting long there.
Oh gosh.
Because I feel like not only has the technology gotten better, but like just the science has just advanced in leaps and bounds.
Absolutely. We've gotten better at miniaturizing things to put them on rovers. We probably have a lot to thank in terms of the development of things like smartphones and other small technology, making things smaller, cheaper, lighter. And we were starting out with missions like Pathfinder and Sojourner, just kind of following the water on Mars. We didn't have a really complicated suite of instruments that we could send. So we discovered that what we thought from orbit, where we landed Pathfinder and Sojourner, yes, this was indeed a place where water flowed across the surface. So then following that up with Spirit and Opportunity, the mission goal there was literally follow the water. So we sent them to two places where we thought we'd see a lot of evidence of water. Opportunity landed in an old playa, so a shallow lake bed that evaporates over time. Spirit ended up in a place that was covered with volcanic material that we didn't quite expect, but then we eventually found evidence of hydrothermal activity there. So warm water interacting with the volcanic rocks over time, and warm water tends to equal life on Earth. So that's pretty great for us. But now we've moved beyond that. Then Curiosity was looking for signs of habitability. So were the chemical conditions in a lake that was in Gale Crater something that could have supported life as we know it? And we were able to answer that as yes. And so now we've taken that final, well, not quite final. The final step, I think, would be, is there life on Mars today? We're taking almost that final step with Perseverance to say, was there ancient life on Mars in another lake setting that is, roughly in geologic terms about the same age as the lake in Gale, right. In a place where we can see from orbit that maybe the chemical conditions were similar and would have been good for life.
Yeah. Yeah, and it's like crazy just to think about the instrumentation too, so Sojourner had what? Just, I think it had one little alpha particle X-ray spectrometer like on the end, and it just kind of went around with rocks, like, right? And now we've got these crazy like pixels, this incredible little machine that can like precisely target grains of sand. We've got these amazing how many cameras are on this rover?
We blow up rocks with lasers on another planet. Like, how crazy is that?
Yeah, no, it's so cool to watch these advance. And I'm even thinking like that one of my favorite parallels to draw is that with Sojourner, Sojourner wasn't, the mission wasn't a rover mission. It was a lander. Pathfinder was the lander, and the scientists wanted to do science with that. And then some crazy technologists were like, hey, let's put this weird 6-wheeled little, RC car on here. We'll try it out and see what happens. And they were like, no, we don't want to do that. It's going to make the mission risky. But then, of course, that bred all of the rovers we've had today, because of that. And we're going to do that again with this one, with Ingenuity. We're going to have a helicopter that is going to, demonstrate flight. And it's the same sort of situation where it's like kind of tacked onto the side of the mission, and it's like not really part of the main thing. But does it mean we're going to have like amazing helicopters in the next 20 years doing all sorts of missions? I hope so.
Yeah, these tech demos are so important to see what the possibilities are for the future. And the public is so excited about, well, not just about, like, we're all really excited about the helicopter. So I'm glad that it got put back onto the mission. It was on, then got de-scoped, and then they put it back. And I can't wait to see like images from the rover, or hopefully even a video of the helicopter just flying off into the distance. Like, that's going to be so amazing.
Yeah, and crashing probably at some point.
At least still make for a good video, kind of like Starship 9.
Yeah, I think it needs to go do some, demonstrate its flight, but then eventually I kind of want to see it crash. It should be like, that should be the way it ends. To me, that's like the just way that mission can end.
You crash it to make a little crater, and then we'll go and analyze it with the rover.
Exactly. Yeah. Cool. So we're just getting our next guest here prepped. Looks like the stream is doing pretty well. We're about 45 minutes out, just coming up on maybe 7,500 kilometers above the surface. So it is moving fast, because when we started, that was a little over 10,000 kilometers. So it's moving at a good clip right now. But that's just kind of how it goes, I guess. The speed at which it enters is sort of the subject of our next guest here. So Anthony, how are we doing there? Are we ready to have Dave on here? Cool. Okay, so we're going to bring Dave up. This is Dave Buecher from Lockheed Martin. Dave, you are the Aeroshell program manager. Did we get that right?
Yeah, I'm the Aeroshell program manager now. Actually, Neil Tice was the program manager. He's retired, so I'm backfilling for him. I did some of the mechanisms, as well as supported some of the programmatics on this program. Like the helicopter deployment system is one of the efforts that I led here.
Awesome. Well, hey, welcome to the show. We're really glad to have you.
Excited to be here.
Really cool. So we were just talking about how fast this rover is going to hit the atmosphere. Maybe you started off with a little bit about, what has Lockheed Martin contributed to this EDL sequence? Talk about a little bit some of the technology that you guys have
Certainly.
built.
Yeah. So for this mission, Lockheed Martin built the Aeroshell, which is basically a protective structure that encapsulates the rover and allows it to go through, you mentioned the high speed, allows it to go through the Martian atmosphere, starting out supersonically, goes through that atmosphere. It protects it from the high pressure as well as the high heat, so it doesn't burn up and break up as it goes through. You can see a picture here on your screen. The white object is the back shell, it's the back half of that Aeroshell. That tan object there on the left-hand side, that's the heat shield. That's the nose of the heat shield. That's another cone. Those two cones come together to create a pocket, or say encapsulate that rover. The heat shield surface, the tan one, it's what really takes the brunt of that pressure and that heat as it drives that atmosphere, and it ablates, or it dissolves as it comes through, and it sheds that energy coming through. It protects the rover. As it goes on through and slows down, it helps decelerate and keep the stability of that aero body coming through. As it decelerates below, well, right before it goes subsonic, the rover will send the command to deploy the parachute. That'll take it then below subsonic speeds, where the rover will command the heat shield to deploy, that bottom half. And that'll continue to decelerate on parachute as well. And then the rover will command the release of the descent stage and the rover. And that's basically a flying backpack to the rover that the rover will command, and it flies it on down to the surface where it wants to go, and it releases itself from that back shell, that white shell you see there. And the
kooky landing sequence, I love it.
It is. It's out of a science fiction movie. They did it on Mars Science Laboratory mission as well. This is basically the same design of that Aeroshell. The rover is very similar as well. It's a little heavier this time around, so we've had to beef some of the structures up, but for the most part, it's very similar. And it is right out of a science fiction movie to some degree. It's super exciting.
Well, Lockheed's built all of the Aeroshells for the rovers at this point, right? So how has that evolved over time from something the size of Pathfinder to something the size of Perseverance?
Certainly. Yeah. You start with Pathfinder. They're much smaller. You can see it on the screen there at 2.6 meters in diameter. You have Pathfinder, you have MER, you have Phoenix. Identical to Phoenix, you had Insight, and all those are about that 2.6 meter in diameter size. Very early on, we had Viking, was a 3.5 meter aeroshell, and then now we're into MSL and Mars 2020. They're both 4.5 meter aeroshells. 4.5 meters is about 15 feet in diameter. It's very large. Wow. And as you move up, it doesn't just extrapolate easily, right? There's dynamics involved. There's pressure fields involved. So things scale more like by the cube of that diameter. And so it's not a linear scaling. You really have to put effort into it, obviously. And like you said, we've been fortunate to be a part of all the landings, the U.S. landings on the surface of Mars, and really have partnered well with NASA and JPL on those. And it's a partnership we've enjoyed greatly, and we hope it continues. But we've learned a lot in that process, and we will keep applying those lessons that we learned and those design evolutions that we go through each time to the next aeroshell. So each one is reaping the benefits of all that hard work and those efforts moving forward.
Yeah, we were joking earlier when we were talking, Dave, about the angle of this cone. So you see on the left there, it's at 70.2 degrees. And I was telling you that I'm a rare super fan of what this design is called. It's the 70-degree sphere cone, just because it's done such a lot of work bringing all of our missions to the surface. Can you talk about what that means? Because I know that's like a very specific Mars number.
It is. You're very right? So we call it a blunt cone angle, right? So it's a blunt spherical cone angle coming in. That cone dictates some of the stability of that vehicle coming in through the atmosphere. So the sharper the cone is, the more bullet-like it is, right? The more stable it is. The flatter it is, it gets a little less stable. Unique to MSL and Mars 2020 are balance moving devices. And so what those do is right before that aeroshell comes in through the atmosphere, it deploys these things called the cruise balance masses, and it allows it to shift the center of mass offset from the center of pressure, or the center of the aeroshell. That allows it to come in with lift. So by having that 70.2 degree half cone angle there that you see, it's a flatter cone angle, and having the CG shifted, it gives it the ability to fly or lift in the atmosphere. And then
it's like surfing on the atmosphere, right? It's
just exactly. Like this, yeah. And it allows it to shift it through and not hit it and impact it as hard, coming through there, and decelerate along the way, which is a big factor when you're that big and you're that massive. And then as you decelerate, you're able to, sorry, keep going.
Oh, no, I'm just impressed at how complicated this is, and the fact that you were able to be successful essentially on the first try with Viking in a completely new environment, a new atmosphere that we never had experience with before.
Yeah, so it takes a lot of design work. We iterate hard on what the requirements are. We designed those requirements. In the world of aerospace, you also put factors of safety or factors to try and compensate for the unknown unknowns. And then we design it, we analyze it, we show analytically or on paper that it's going to work. Then we test it. And when you go through and you test it, you also work out some of those warts and kinks, and you're able to finalize on that design that you've tested to environments that are greater than the environment you'll see come entry day. And so you're very confident it's going to work going through there. But all that said, you're right. It's a very dynamic situation. It's all autonomous as it comes through, right? The rover gets kicked off, the entry sequence goes, and then it does its thing. So you have all those dynamics. You have the autonomy. You've tried to put in all this fault protection and logic into the rover to help it control itself as well. And you've tried to design it for all those what-if cases. But there are unknown unknowns and events that happen. So it's a dance.
Yeah. So you mentioned about all the things, like doing all these iterations and learning from each one of them and trying to feed forward that knowledge to the next design. Can you talk about what's shiny brand new on the Perseverance aeroshell that we didn't have on landers? What are the innovations that we're having with this technology?
So from the aeroshell side, as I said, we strengthened up the heat shield itself because the rover is heavier. And in going through previously, the Mars 2020 aeroshell was designed for the mass of that rover, and this rover is heavier. So we had to go back, redesign that heat shield, strengthen it up in areas to kind of change how the load is spread through that aeroshell. Also unique to this mission, it's going to be the first mission to fly a helicopter on another planet. Right? How cool is that? So JPL designed the helicopter. We designed the helicopter deployment system. That system lives on the bottom of the rover. And so that's new for this mission. And so we worked with JPL to try and figure out what are requirements to fly in an atmosphere that's so thin. And how are you going to package a helicopter that's super lightweight, that's going to fly in that lightweight environment, and package it, get it down safely through this severe environment coming on down all the way through landing, and protect it all the way down. So that was some of the new stuff that we had to work with them to partner and develop with.
Yeah, I'm excited. There's an instrumentation package on Perseverance called Medley 2. And I will not remember the acronym, but basically they're measuring the temperature, the pressure, all the different things on the outside of it. So it should give you guys just like a buttload of new data to read and learn from, right?
Well, so you're right. So we had Medley on Mars Science Lab, or MSL, and that was just local to the heat shield though. And those are temperature and pressure sensors. And so you can get a measured data coming through the atmosphere and trying to understand how is that thermal protective system working, what's really happening inside from a measured, quantitative type of way, versus just looking at it through simulation. In Mars 2020, they've upped the ante. Now they've moved Medley, or Medley 2, up until the back shell as well. So you're getting temperature and pressure from the leading surface and from the back shell surface. So you're getting those eddies and that back and wake effects.
I'm excited because there's a microphone on it, and that's just going to be the audio for me to put on.
And cameras.
And cameras, yeah.
Yeah.
It's going to be pretty awesome.
So you can hear carbon dioxide. No.
Dave, this is awesome. I really appreciate you coming on to share this today. This technology is just super cool, and I'm so stoked for you guys to put another notch in your belt today. Knock on wood, everything goes great. Thanks for sharing all this with us today.
Anytime, glad to do it. Thank you for having me on.
Yeah, no problem. Cool. All right, so we are 35 minutes away. Tanya, how you feeling? Let's do a nerve check here. Are you feeling good?
I feel like the closer it gets, the more anxiety-inducing it is.
The nice thing about doing this stream is that we're just busy and like we're focusing on this, and it kind of helps me clear my head. Because if I was just sitting in front of Twitter right now, I don't think I would be in a very good mental state.
Yeah, and the time flies by. Like the last time I really looked, it was 50 minutes, and now it's 35. Like we're gonna blink, and it will hopefully be on the surface.
Yeah, I hope so. Hopefully. So I thought maybe we have a little bit of time for our next guest here. But we talk a bit about some of the landing accuracy that this rover is doing, because this is a pretty big story with Perseverance, I think. So, when these rovers come in, they don't have any spacecraft. They don't have like a precise spot on the surface that they can target, because it's just everything's a little dynamic, depending on what kind of atmosphere you hit, blah, blah, blah. We have a picture here that shows sort of these landing ellipses. And think of this as like your cone of uncertainty, right? So inside that oval is roughly where you think you're going to land. You're going to shoot for the middle, but you may not necessarily get there. And if you see that way outer band, you can see a little bottom underneath the logo there. That's I think Pathfinder, which was 1997. So huge ellipse. And every time we do one, we get smaller and smaller. So Phoenix Insight was a little bit smaller. Then you can see Curiosity, and look at Perseverance. Look how small that is compared to the other ones.
It's amazing. I mean, if you look at the size of these other ellipses, even up to Insight, we wouldn't have been able to land in a crater like Jezero because it's just not big enough. And even just seeing the difference between Curiosity and Perseverance, they're using very similar systems in terms of the sky crane. But because you have things like the terrain relative navigation and some of the other improvements to the landing system, it's so much tighter than it was before. So we can land way closer to the delta, which is our feature of interest, than Curiosity was able to land to its feature of interest, Mount Sharp, inside Gale Crater. So that means less driving time and more time for science.
Yeah, I mean, just think of imagine if you were working with Phoenix's ellipse right now and trying to target that spot. You could land way off on the right there, and it would take you 2 Mars years just to get to the delta, right? Which is like not ideal. So that's pretty cool. You mentioned the two technologies. So the first one is range trigger. Do you want to talk about that one? That's we kind of mentioned it. That's the parachute one, right? So that's Go ahead if you want to talk about it a bit.
Oh, basically just using radar to figure out how far away are you from the surface, to figure out, okay, now that I know where I am, what is the sequence of events that I need to do, like triggering parachute.
Yeah. And that's the dynamic event that's going to really throw my timeline into disarray. We'll see how it goes. And then, the other one is the terrain relative navigation, which I think is actually really key because of this delta. So you can kind of see in that middle of that circle there's like a sharp cliff. This cliff is crazy. It's like 200 feet tall. And it would be no bueno if we landed on that. Like we cannot do that, right? So this terrain relative navigation basically takes pictures of the ground while it's coming under a parachute, compares them to the images from orbit that they store on board the rover, and it figures out where it is, and then it can do divert maneuvers to try and avoid those rocks and those cliffs and all those kind of things, which is, it's mental. So I'm just so excited for this technology to make landing even better. I can't wait.
It's a huge difference from lobbing airbags at the surface and seeing where you stopped bouncing.
Exactly. Yeah. Well, I was going to say too, so we have the Pathfinder ellipse on here. The Viking one's even bigger. It's so big, it's not even on this map, because like the entire map is inside the ellipse. That's how big the Viking one is. So we've really come a long way. Well, we've got our next guest ready to go here. So maybe we'll just jump right forward and get him on, and then we can spend a little bit more time with him, because he's got some really great stories. Mike Seibert, welcome to the stream, Mike.
Howdy, good to be here.
Hey, nice to see you again.
Jazzed to have you. So Mike, why don't you maybe introduce yourself and just talk about some of the work you used to do when you were at NASA JPL, so that we have some context for what your expertise is.
All right. Yeah, I'm Mike Seibert. I spent 12 years on the Mars Exploration Rover team, so that's Spirit and Opportunity. And I did many different things on that project, everything from the ground system, so making sure the data, once it gets out of the Deep Space Networks system, gets over to the project system, decodes it, and is made available to the scientists and engineers to figure out what they want to do to the next cell. Spent some time on the sequencing team, and that's where you actually put together the commands that go up to the rover. Includes everything from trying to organize what science can you do with the rover that day, all the way up through, I was a rover driver for 4 years. And I also spent some time on the engineering team as the lead flight director, where you're taking care of the entire rover as a spacecraft, making sure all the systems are healthy. Also spent 6 months on the MSL team, doing a little bit of support while they were working in the test bed to figure out how to drill again after the drill feed mechanism got stuck a little bit. And I spent a whopping 8 hours working on Mars 2020. I was part of a peer review board for their mobility subsystem. It was a fantastic review, lots of amazing new technologies coming online with this rover.
Yeah, man, between you and Tanya, I'm going to be like just completely outnumbered by rover experts here. I feel really outclassed. So do you want to talk a little bit about, so the reason we wanted to have you on here, Mike, is because you have this operations brain. So you've talked, about the different rovers you've worked on. You've got all this experience. I really wanted to understand what is going on in the control room here, because there's just a lot of weird dynamics here. So first of all, I mean, just what does it feel like to be in a rover control room?
So just the first disclaimer for everyone, I have not actually been in a control room for a landing. I joined Spirit and Opportunity like 18 months after they landed. So, but it's definitely interesting, especially when you have what's considered real-time events. So real-time from the rover perspective, not from those of us on Earth, because right now there is about a 11-minute and 25-second one-way delay for the signal from Earth to Mars, or the reverse. So you end up putting together these commands that, instead of doing a single, let's drive 10 meters, send the command, wait for the rover to do it with all the time delays, and hope that if you were doing a drive that takes 5 minutes, there wasn't a cliff 4 minutes away. That would be a bad day, especially if the one-way light time can get up to 20 minutes. So you plan entire days. So you get a day's worth of data back, or about a half day's worth of data. All the critical activities happen. The data is sent back through the orbiters we have at Mars, and the engineers pore over that, make sure the rover's healthy, that the rover performed as expected. The scientists pore over their science data to see what new findings there are. And then you go right back into a new planning day, where you get to debate what science activities need to happen. Where do you want to drive? Do you want to use the robotic arm? Do you want to drill into that rock you are parked right in front of? All of those decisions. And then you very quickly have to take all of that from just effectively ideas on the back of a napkin and start turning them into actual commands with a bunch of reviews. You go over the commands many times, you edit them, you adjust them for new information that's come in. But at the end of the day, you have to have a good command set to send up to the rover so it can execute those commands in the next sol. You go home, try and get some sleep, rinse and repeat, potentially for up to 14 years.
For 14 years, yeah. That's the Opportunity rover that went slightly over schedule on its
little
prime
bit.
mission. Yeah. Originally planned for 90 sols, went a little bit longer than that. So can you talk a little bit about I know I'm reading a lot about the ops team is going on Mars time, kind of. Well, they were kind of already on it. I know they don't do it for the whole mission, but like, what does that mean to be on Mars time? Because this is a very fascinating operational problem that I just like love my brain kind of going off on.
So the Martian day is about 40 minutes longer than an Earth day, which is just enough to be completely annoying. It may sound great that you get to sleep in an extra 40 minutes every day, which is nice at first, but then when you start waking up later, like 4 p.m., it gets a little bit tricky. I've only been on Mars time once. We switched to Mars time to try and get Spirit to its third winter haven at the north edge of the home plate feature, which was interesting. So we ended up starting shifts at 4 or 5 p.m. They'll rotate through the night. But the reason to do Mars time is if you tried to work just the 9 to 5 planning, the Mars day would move around compared to 9 to 5 on Earth. And then you sometimes get to the point where the data from the previous day doesn't come down in time for you to start planning. We would call those restricted planning shifts, where you're using data from one sol away from where you're actually going to start planning. But on Mars time, everything is what we call nominal planning. You have data from the most recent sol, you have the most recent engineering state, the most recent science information, and you can take action and move on from that. It's used early, especially right after landings, to do vehicle checkouts, make sure the vehicle's operating as expected, send up any commands that you need to just to get the mission underway. And then once the vehicle's stable, you can move on to Earth's time or a modified Mars time as needed to give the team a little bit more of a normal sleep cycle, because Mars time will burn you out. I've heard stories of scientists that tried to work Mars time for both Spirit and Opportunity during prime mission, and surprisingly, they made it about 50 sols before they were completely exhausted.
That sounds horrible.
Yeah, it was a terrible idea.
Yeah, that's not good. And it's really interesting this year because there's, with the pandemic, a lot of these people are working from home. So they're doing Mars time while trying to coexist with a family on Earth time. And it's like, it must just be a whole thing for that. I can't even imagine that.
I did Mars time with a roommate and a dog. And thankfully, my roommate was able to help take care of the dog when my shifts started slipping into the late evening. But yeah, I cannot even imagine how folks are going to be doing this with families and pandemic and everything else. That's the type of operations team you have. That is just another problem that needs a workaround, and they're going to figure out how to deal with it to make some good science and good engineering happen on the surface of Mars.
Yeah.
So if we go back a little bit, you were mentioning like the time delay and sending commands to the rover all at once. Since there's nothing that the engineers can do in real time during this whole landing sequence, what is everybody doing in mission control other than panicking and hoping that everything is working as it should?
Watching telemetry. I've even when we would get the burst downlinks once per sol through the orbiters for Spirit and Opportunity, you can still watch the real-time information. There's nothing that can be done when they see the information come back from top of the atmosphere. Perseverance has been on the surface for 4 minutes, so there's not much you can do. But right after landing, if things look weird, let's say there's something that's drawing power that got stuck on due to some event during landing, a command could be sent to potentially rectify that. So knowing what the rover state is the moment it hits the surface is still incredibly important. But also part of it's just folks have poured their past, several years of their lives into this, and this is where they get to watch how the system that they are the expert in performs. And I'd want to be able to keep a close eye on it too. But the nice part is with the time delay, if landing ends up being successful, just like the past rovers, you can jump up and down, you can high five, because there's really nothing you can do about it because you're watching an instant replay. So you can actually let all the joy go through. It's not like when the space shuttle's trying to land and mission control can do something about it, can work with the crew. They can send instantaneous commands or voice instructions. It's a replay, so you might as well enjoy the thrill of it and then figure out what state the rover's in and get it squared away for the first sol on Mars.
Yeah, it's a bit different than a human spaceflight mission, right? Whether we were in low Earth orbit on a spacewalk or something.
Yeah.
So are the Sol 0 commands already on the rover at this point, or do you wait until you know it's successfully landed and then send the start deploying things and open up lens caps and stuff like that?
It should be a combination of both. There should be some pre-stored. Some may have to get commands to trigger those sequences to execute. Potentially, some will automatically execute. But things like deploying the camera mast will be done well after the initial checkout of the vehicle health, because you don't have to deploy the camera mast right away. That's not a critical event for survival of the rover.
Right.
But other things like sending back the specific detailed power telemetry, because the moment the cruise stage separates, the rover is effectively running on its battery. The RTG can trickle charge the battery, but it's going to draw almost all of its power from the lithium-ion batteries on board. So you want to make sure those batteries are healthy right away. So some of those automatic commands to switch power loads may occur just the moment it detects it's on the surface.
Cool.
Okay.
I have one more question for you as we're getting close to the end here. So we've been talking about the peanuts. We have peanuts here that we're ready for the good luck. I bet you have some too, right? Yeah.
Of course.
Can you tell the story? You probably know the story better than anyone. Like, what is the story behind the peanuts? Why does
it was one of the early Ranger or Surveyor missions? I always forget which one it is and always get it backwards. So I'll just say it was either of them. There were launch failures. You'd miss the moon. You'd crash. Bad things would happen. And then peanuts were provided in the dark room, and magically the next mission succeeded. So at that point, because we're all a bunch of rational engineers and scientists and we have no superstitions whatsoever, peanuts became a mandatory thing for all critical events at JPL. And even for those of us that are no longer at JPL, we still carry on the tradition and make sure that for critical events of spacecraft we care about, that we have peanuts on hand.
I'm surprised I've never seen like JPL branded peanuts in the gift shop before.
Not in the gift shop, but I have seen them in the dark room. They'll put a custom wrapper around the outside, mainly because it doesn't look good if on national TV a government-funded agency is holding up whatever brand of peanuts they happen to buy that day. So they have probably a nice wrapper around them that say Mars 2020 landing.
Oh, geez, it's like Tang all over again. Hey? Cool. Well, I need you to help me out though, because I was just saying earlier, I bought dollar store peanuts. They're very low quality peanuts. Have I cursed the mission?
No, they're peanuts. It counts.
Okay,
I don't think anybody knows what the original ones were. So as long as they are peanuts, and for those of you with allergies, find your own workaround and something that works. I've seen folks that have peanut allergies that have gone with salted pretzels. So find something that is your good luck charm food.
Perfect.
Yeah, please don't go into anaphylactic shock for the sake of the rover.
Yeah.
No, that health and safety of the humans takes precedence over the vehicle. So yeah, don't do that.
Yeah. Awesome. Well, Mike, this has been awesome insight into, like I said, into ops brain. Just how do we manage these missions? Because we are all people at the other end of this at the end of the day. So thanks for sharing all this today. I will let you get back because you probably want to kind of lock in on the feed, and you've probably got your peers that you're connecting with. So
yeah, it's going to be a good time. But I'm looking forward to hopefully the first time since November of 2008 we'll have 3 functioning surface vehicles.
That's right.
So exciting.
Yeah. It's going to be great.
Good to be cool.
Well, thanks a lot, Mike.
Yeah, you're welcome.
All right, Tanya. So checking in here. We are.
It's less than 20 minutes.
Yeah, less than 20 minutes. We're just about 2,000 kilometers above the surface here. So a little bit about what's coming next. We've got a little bit of mission critical events about to hit. So you see on the timeline there, L- 17 minutes or so. That's cruise stage separation. So that is the first thing the spacecraft kind of really does that's visible. So we got that coming up right away here, and then it does some despinning. You'll see the balance mass ejection. That's what Dave was talking about. So it's going to throw that little mass off to the side so that it can steer. How you feeling checking in?
The fact that engineers figured out that they could do that just still blows my mind. Like, we're just going to shoot some mass off and wiggle ourselves into the right way that we won't burn up in the atmosphere of this other planet.
Well, I especially like too because you can steer by rotating. So if you imagine, like if you're coming in like this, I got my peanut lid here. If the center of gravity is off, then you can kind of create this lift. You can surf up, but then by rotating around, you can move which direction that points the lift. So they can do S curves with these things in the air. They can bleed off energy to come sooner, or they can not do that and go further. It's crazy what they can do with it. I can't believe it.
Yeah.
So Anthony, Matt, why don't we bring the stream up here? We'll take a look at what's going on. Maybe we'll bring the audio on as well, and we can listen into the loop and see what's happening here as we approach cruise stage step. Seems quiet so far. I'm curious to see how accurate we are with our timeline. This is the big first test. We'll see if the animation lines up.
Tones from Perseverance coming by for cruise stage separation.
RCS priming.
So it looks like maybe we're a few seconds ahead.
Ooh!
That's pretty good, yeah. So maybe Anthony, maybe let's add plus like 3 seconds to that, and we'll bet you we can, or actually be subtracting 3 seconds because it was early.
Cruise stage separation has been confirmed by the spacecraft.
This is the first time we've had a real-time sort of animation like this during landing, isn't it? I don't remember this for curiosity.
Yeah, I don't remember. I don't think they had this.
Preparations for entry. The first action it will do is to fire warm-up pulses with its entry thrusters. These pulses ensure that the spacecraft gets the thrust that it wants during entry interface. We're about 9 minutes from entry interface.
Okay, so yeah, so it's gonna stop its spin now. That voice you're hearing, that's Swati Mohan. She's the voice of EDL, so she's going to be giving all the critical stuff that we want to hear today. We're getting into it here. This is the thick of it.
It's like, what's your pulse right now? I can feel my heart beating faster.
I have a Fitbit on, so I can look. Let's see if it'll tell me here. 95. That's a little high for sitting down for the last hour.
I feel like I have to put my Apple Watch back on now and see what it comes up as. I had to turn it off because it was buzzing from people asking if I was watching the live stream, and I couldn't answer them to say, no, I am the live stream. Let's see.
Entry capsule and Earth, so we saw a little blip, the data stream indicating two-stage separation.
Oh no, maybe I don't even remember how to check my pulse on this thing.
Warming up those entry thrusters.
Anthony, if you want to maybe bring the loop up, maybe 10% or something. Cool. Okay.
At this point, the spacecraft is trying to stop its spin.
Yeah, we're getting it's a mono channel for some reason.
Zero, and then we'll turn to its desired orientation from entry. It will separate the two balance masses that has kept it balanced during all of
Yeah,
cruise.
they've got kind of two different things, I
the
think.
capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the
we can hear you.
Entry attitude.
Yeah, the stream can. Anthony, our producer, is talking to us in our ears here and giving us things about the stream. But so we've got so that's the despin. The balance masses are out. We've got about call it 6 or 7 minutes here before more stuff happens, before we hit the top of the atmosphere. Instead of sitting here and listening to our heartbeats, Tanya, I thought maybe we would just talk a little bit about some of the other work we're doing. Do you want to maybe just share a little bit about your book and kind of the what you did with that? Because it's such a cool story.
Oh, you mean this conveniently placed thing right here?
Oh, yeah. I didn't see that there. That's really nice you had that so handy.
That I have to give credit to my co-author, Danny Bednar, for that, because I didn't have it set up where you could really see it on my shelf. So this book, For All Humankind, was inspired by wanting to hear stories about what the moon landing was like for people that watched it or listened to it live as it happened, but did so from outside the United States. Because at least in the US, we always hear this very patriotic version of it, Americans versus Russians racing to the moon. But I had a conversation with a professor when I was working at ASU who was from Sudan, and he told me his story of watching the landing at his university in Khartoum when he was like 22. And it made me curious to hear more of these stories. And so I partnered with Danny, who is a human geographer. So I figured he knows how to talk to people since I only know how to talk to robots. And we tracked down 8 people who ranged from, at the time of the landing, a 5-year-old girl in northeastern India to a 44-year-old Holocaust survivor from Lithuania who had immigrated to Canada via Africa, and heard all of their stories about how the moon landing affected them. And the key here is that these generally weren't space people. These were just normal folks that watched the landing and they were impacted by it in some way. And the beautiful theme, kind of a spoiler, but the theme across all the stories from people was that they felt like this was a human achievement. It brought everyone together to do something bigger than humanity. And I feel like Perseverance is kind of doing the same thing, looking at the excitement on Twitter, I guess not just for Perseverance, but for Hope and Tianwen getting to Mars earlier this month. It's not really a thing about borders. It's a thing about humanity and science and exploration. And it's really amazing to see how many people feel like they're a part of it, even if in their day-to-day life, they're not attached to it at all.
Yeah, this book, I have it too, so I have a copy here. This was really good. What I would recommend about this book is that if you thought 2020 was like a tough year and it got you down, this is a really good a spirit lifter. It's like a very wholesome book. I sat down and read it in one sitting. It's very digestible, and it made me like people a lot more after I read it. So it was a good book to read. So I definitely recommend it. So again, For All Humankind by Tanya Harrison and Danny Bednar. Fantastic.
We're currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
All right, everything's good to go. 4.5 minutes from the entry interface. I want to just share a little bit about some of the stuff that we're doing for merchandise. So I have these cool. These just came in. I'm so glad they came in time. These are our season 5 mission patches. So I'm going to shamelessly plug this. This is art by Beth Kerner, who does illustrations, some fantastic work, and she's been done all of our mission patches every year now, and it's celebrating all the missions. So we got Perseverance here on this side, we got Tianwen over here, and then Mars Hope on the top there. So these are awesome. You can get these on our shop. That's shop.wemartians.com, and if you want, you can buy all 3 seasons for a combo pack. So that helps support the show, and it also helps support an independent artist like Beth. But if you're new to the stream as well, like I said, I do podcasts regularly. So WeMartians.com. We've been doing a lot of really cool podcasts lately. We had Sarah Alamiri on just last week, which was a really fun interview for me to do. She's the head of the UAE Space Agency. So it was 2 days after the Mars Hope arrival. She was beaming with joy. She was just so much fun to talk to. And she's very inspiring as well. So that's an interview I definitely would recommend you listen in on. It was a lot of fun. And if you like the show, this is my job, and so I do work for this on Mars all the time. Patreon.com is how I pay the bills. So if you want to support this, small monthly fees as low as $3 a month can help me do the work that I do. And I really appreciate it.
You missed out, Jake. You also have awesome shirts.
I do have awesome shirts. Yeah, I'm wearing my Perseverance one today. I don't know if you can see this with the wheels.
Nice.
And then you've got like an OG Martian shirt. That's been out there that's one of the original ones I did.
I'm surprised it's still in one piece. That tells you something about the quality, because I wear this shirt like anytime I do anything. Even though I make shirts too, I love this shirt more than any of my own shirts, and so I always wear yours.
Well, I really appreciate it. We have a couple minutes for entry interface here, and I wanted to also just give a chance to our producer Anthony to come on, because he's been doing all this hard work behind the scenes, getting our guests up and running and popping in, and he is not actually a full-time video producer. That is not his job. He does some good work as well. Anthony, why don't you tell everybody about your podcast?
Yeah, we invested in Rode audio gear at the beginning of 2020, which was useless. So instead what we did was double down on video from a home studio. But yeah, I'm running main engine cutoff by day, but I am by night Jake's video producer for all things Mars, in which I am not that relevant. But it's been a lot of fun. Feels like everything's going well here on the stream. We're now within the window in which this has already happened at Mars, and we're just waiting to find out, which makes me extra nervous. So
it's Schrodinger's rover at this point.
It totally is. So yeah, I'm excited to be here, but I don't want to be in the way of between you and Mars. The most dangerous place in space is between Jake and Tanya and Mars, is what I always say.
Yeah. Well, I would just say, you've done some great interviews recently as well. You cover space flight, rockets and satellites and industry trends. You had some awesome interviews with, I'm just thinking of with Megan Crawford recently, which was about space VC funding, which was super interesting. How the economics of these companies work, and I know a lot of these companies, they're making things like Perseverance happen today, and so it's important storyline. You did an awesome job with it.
Well, I appreciate that, and I don't know if we're spoiler alert, but we're going to be doing some crossover between We Martians and Miko coming up in the wake of all the Mars mayhem. So I think listeners will enjoy both sides of that conversation coming up soon.
All right, so let's get back to the stream, because we are. within a minute of entry interface. So this is where the action starts. This is, Tanya, this is 7 minutes of terror. We're about to do it. Are you ready?
Yeah. Oh, my heart is starting to increase. My friend literally just texted me how to check my heart rate on the Apple Watch. Like, I put it back on now. Let's see.
I've climbed to 100 now.
Above the surface of Mars.
Yeah. Okay. Where is the heart icon?
I have to make my screen bigger.
This is terrible. I can like work on rovers, but I can't operate an Apple Watch.
5.3
Okay, measuring.
second and an altitude of about 150.
Oh damn, we're less than 7.
Okay, yeah, and it sounds like our altitude's pretty close here because they were 115 kilometers a second ago.
Nice. Oh, here we go. 8 minutes ago, I was at 71 beats per minute, and now I'm at 91. So we have scientific proof to the audience that we are legitimately, like, emotionally invested in this.
Second at an altitude of about 120 kilometers from the surface of Mars.
Yeah, it looks like our audio's fixed here.
There's so many things popping up now in your status bar on the side. I guess over here.
Feeling the atmosphere
over there.
of Mars slow it down. Once there's enough atmosphere, it will start controlling its path to the landing target.
Doppler indicates entry into the atmosphere.
This is fast stuff here.
Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule.
So we're getting up to like
velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are
so it's heating up. It's getting a lot of G-force and a lot of heat energy now.
Bank 1 completed.
I'm so nervous.
Properly indicate reversal, bank reversal.
We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
Wow.
Lock again. Doppler indicate reversal. Bank 2 complete.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
This is those S-curves.
Reversal.
End of range control, range minus 1.9 kilometers, cross range minus 2.4 kilometers.
Should we start nervous eating the peanuts now?
Yeah, I don't want to like fill the audio with my nervous crunching.
At an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but
I think we're a little fast on the
timeline.
timeline.
Mars,
yeah, maybe you want to.
Flying straight to the target.
We're ahead, so add some time to it. Maybe 5-10 seconds. Oh, too far.
Oh, we've switched from space view to Mars view. This is getting real.
Here now.
Oh my God, 3.5 minutes. Woo.
I think we're okay. Let's stick there for a bit. So this next stage here, this is the straighten up, fly right. So this is actually where it throws the other side balance masses out
about
and recenters itself.
And 50 meters per second at an altitude of about 15 kilometers from the surface.
Look at that. Look at that view.
Good telemetry log.
That's so cool.
We're coming upon the start. We are starting the straighten up and fly right.
UBMD jettison.
Where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Doppler indicate chute deploy.
All right, so
navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
That's still an insane velocity.
Yeah. Not a lot of atmosphere to slow down against.
The fact that we can build a parachute that doesn't rip apart at those speeds.
Perseverance has
wow.
slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is
breathing in the air.
145 meters per second at an altitude of about 9.5 kilometers above the surface.
I'm like shaking in my chair. The landing video when we get it back is going to be so cool.
It's going to be off the charts, yeah.
Oh.
This is crazy. So the terrain relative navigation we talked about is coming up.
Nav filter converged. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars.
So it takes about 7 seconds to get its solution with terrain relative
Perseverance
navigation.
is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Now this is scary since this is new. We've never done this before. On Mars, at least.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
It's flying now.
Back shell set.
Is 83 meters per second at about 2.6 kilometers from the surface
I
of
want
Mars.
to add 5 seconds or so.
Confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Oh God, we're so close!
Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
SDS level.
Constant velocity
104.
Constant velocity accordion, altitude air.
We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost Earth tones.
Throttle down.
Sky crane maneuver has started.
Yeah, we're a little ahead, but that's okay.
About 20 meters.
Tango Delta.
That's it. Oh my God.
Nominal.
Tango Delta. That's TD, touchdown.
Remu stable.
Gotta wait for the cheers, though. They're all holding it in.
Come on, come on, come on.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Oh my God.
At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Wow.
Oh, man.
That never gets any less tense. It doesn't matter how many times we do it successfully. Like, it is always still really stressful.
Oh, man. How did I get to? Oh, yeah.
Yeah, like, what's the heart rate now?
How's that
They're still getting telemetry from the lander.
Hey, that's good.
110.
You beat me.
Touchdown confirmed.
Cool.
We're gonna wait for the images.
Yeah, so right now what we're waiting for is Perseverance is going to try and send a picture right away with the HAZ cams. These are the cameras right in the front of the rover. They still have the dust covers on. There are these transparent dust covers to protect them. So we're going to get something dusty, we hope. It'll be like kind of dust on the lens, but it should show the ground. I know when Curiosity did it had that beautiful shadow kind of right in front of it. I don't know if we'll get that depending on the orientation, but it should give us something within the next 10 minutes or so to look at to prove that we are on the surface, and that's what we're all waiting for now. That was incredible.
I'm so glad all of those pieces worked.
OL1, you have what you need?
OL3, I have what I need. Flight, we have seen the completion of EDL 3000.
Copy.
Copy activity. That is as expected.
That deep breath is how everyone's feeling.
Flight, this is OL3. I am ready to share.
OL3, you are go.
What is he going to share?
For those on M.
All stations stand by for the images. Yes! Woo!
Yeah.
It's so small.
It's a crappy photo, but it works.
It's a crappy photo of Mars.
Yes.
That's what really matters.
OL3, I have the target point on the map when you are ready.
We are ready, OL3.
Ooh.
Go for it.
Let's see where we landed. Well, they're getting this fast. I didn't think they'd get it that soon.
This is so much faster than I thought it would be.
Yeah.
There's been lots of betting pools over where in the ellipse it's going to land.
I couldn't see it. I don't know if they're going to bring it up closer.
Flight, I'll be moving in, showing you the safe zone that we've landed in.
Oh, look at that.
Whoa.
That's less dusty than I thought.
Yeah, it's much cleaner than Curiosity's first image.
Yeah, Curiosity's was really hard to see.
OL flight.
Keep us hanging.
Oh,
TRN. TRN.
TRN, Terrain Relative Navigation.
Can we get the cliff image, OL?
Yeah.
I really want to see where we are relative to the delta. Like, how close did we get?
OL, can we get the other image? Should show the cliff.
I'm sorry. Say what image again? I'm not understanding.
Flight OL3.
OL3.
You can
I can't see the X.
We've landed about 35 meters from the nearest rocks that we could identify from orbit by their shadows.
Copy OL3. TRN in action.
Yep. Take that, Desero. Woo!
I remember this spot. It looks good.
Copy OL3. I'm sure that you have seen them all and you recognize them all. So
there's the wheel.
Oh, here's our next view. Yeah.
Flight
reports Electra still in lock with the lander.
Flight, we have seen the transition to surface. EDL is done.
Now they're like a software mode, right? It's moved off of EDL mode onto operational mode. That's great.
All stations.
Sol zero. Officially.
We'll have to see if we can get that.
Perseverance team and the whole team that's not here as well. Excellent job.
I'll have to see if we can get that landing map and figure out where it landed. I don't know, maybe Anthony, do you think it's on the other stream? I think they're a little closer about showing it. Maybe you can see if you can find that. Yeah, maybe someone's tweeted it too. There's enough cameras in that room. We should have
EDL ops. We have transitioned to surface as reported downstairs. If you are part of that story to the surface team, make sure you're starting to work those inputs, please.
They're split over like 3 rooms for this one, hey? Like I remember, because in Curiosity, they were all jammed into that one room, but it looks like for safety, because this is the main control room, like where they operate from, I think. And then the straight desk was like the one where Curiosity landed. And there's also some other auxiliary room, it looks like.
Yeah, everyone is so spread out. It looks so weird, comparatively speaking.
Yeah, I don't know. Okay. Well, Tanya, that happened a lot faster. We didn't have to hang around too long to get the confirmation that we needed there.
Yeah, I can't believe we got images so quickly. I mean, it's only 12-minute delay, but it always feels like it takes so long to get to see that first light once you're on the surface.
Yeah, when we were preparing for this, I went and watched the whole Curiosity landing sequence to try and like familiarize myself with it. And so I budgeted 10 minutes after this for us to like wait here for that picture. And it came in like 45 seconds. It was amazing. That's awesome. Oh, I feel so good. Are you relieved? Yeah, it's coming off your chest here. Like what's it feel like?
I can feel my heart rate is still very fast, but now I think it's out of excitement instead of nerves. Like I can't wait to see what this brand new place on Mars looks like that we've never seen from the surface before with a brand new rover. Oh, it's a whole new day for Mars exploration.
I want to announce to everybody I've taken a first pass at the surface transition report. I've got some numbers from the script, and I'm awaiting inputs from a couple people still, and confirmation from others. It's ready for review.
Yeah, you know what you said, Tanya.
Is ready for review. Are you asking people to take a look at your cache report?
That's right. It's ready for review. I'm looking for confirmation from a handful of folks on some of the values before making it final.
Copy. Do you want that confirmation over this net?
The process is to work it over email. I've sent out an email that they can reply to.
Thank you.
Email processes. All right. Yeah, I think we can turn that stream down. I was just going to say that you mentioned it's a whole new time for Mars exploration. I'm still like stressed out here. I'm just so excited for learning a new place, right? So, I mean, for the last, since Opportunity left, the last 2-ish years or whatever, I've been covering Curiosity and Gale Crater and, following that whole story, getting off of Vera Rubin into Glen Torridon and learning the clays versus the irons. And now we're over that pediment and then the sands of 4V and just like really being intimate with all these place names and like really feeling like I get to know this area. And now we get to do that for a whole new area. Like we're going to have to start naming these things and learning about the cliffs and the rocks and the path. And it's just so exciting. I can't wait.
Yeah, and once we get to see that map of where it landed, like relative to the Delta, that's going to answer so many questions. Are we going to get to the Delta in a month, in 6 months, in a year? I hope it's sooner rather than later. Like, just get in and start doing the science.
Yeah. Well, I think our show is just about done here. So I want to just say thank you to you, Tanya, for co-hosting with me again. This was a lot of fun. It's always fun when I get to work with you. So thank you.
Thank you.
And then thank you to all of the viewers on YouTube and all the listeners of the podcast. Really appreciate your support. I know that everyone is very excited about this. It was really great to see all the fun on Twitter and in the Discord and then here in the comments on YouTube. We really appreciate all of you tagging along with us for this very exciting day. So I guess we will bid you all adieu. Ad Aries, everybody.
Bye, everyone.